Hi everybody, this is Mrs. Hennefarth, part 2 of this video on lesson 14 and 15. So we're going to go ahead and get started with owing interest. So what I'm going to do is I'm going to cover this up, and what I'd like you to do is we're going to read this. To get a new computer, a recent college graduate obtains a loan of $450. She agrees to pay 18% annual interest, which will apply to any money she owes. She makes no payments during the first year. So what I'd like you to do is just take a moment, highlight, annotate, circle, maybe jot down some things that you know about this problem that you can get and write it down. So in this problem, we know that this student is getting a new computer. We know that she's a recent college grad. We know that she's getting a loan. A loan is when you don't have the money. So obviously she needs $450 to either buy the computer, or maybe she's got a certain amount and she needs the rest of it. We also know that she is going to be paying 18% annual interest, and it's going to apply to any money she owes. She also makes absolutely no payments during the first year. So that means that money is going to accumulate on what she owes. So again, 450, agrees to pay 18%. I want to note that that's 0.18 as a decimal. Annual means yearly. Means she's going to be paying 18% on a yearly basis. And she makes no payments during the first year. So that means that she's going to owe 100% plus more, just so you make reference of that. Okay, so what did she start with? $450. That's what she gets a loan for. Question number 1. How much money is she going to owe at the end of 1 year? Well, just based on what we know right now, we know it's going to be more than $450 because she's making absolutely no payments. We also know she's paying 18% interest. What's interesting here, though, is that she has borrowed and paid nothing for that first year. So we have to make sure that we count that. So again, we know she borrowed $450. We know that makes no payments for the first year, and we know that she has got an 18% interest rate. So right here, 450 times, I'm just going to add 1 plus 0.18, which means this 100%, because she hasn't paid anything, and 18% more in the year. So how much money is that altogether? It is $531 in the first year, year 1. Okay, so now moving on. Question 2. Assuming she continues to make absolutely no payments to the lender, how much money will she owe at the end of 2 years and then 3 years? I want you to think about that. And based on what we saw up here, what's going to happen after 2 and after 3? So hopefully you've kind of thought about that, and we know that if at the end of 1 year she owes $531, so if this is at the end of 1 year, well then we have to tack on another 100% plus 18% more, because that's what she's going to owe at the end of 2 years. So if we do that, that makes a total of $626.58. So what does that mean that's going to happen at the end of 3 years? Well, 3 years, we've got the exact same thing. We have 100% plus 18% on top of what she owes right here, 626.58. So if I go 626.58 and I multiply that by 1.18, this means at the end of 3 years, she's going to owe $739.36. So let's just look at this. She started with $450 at the end of the year, $531. How do we get there? We took 100% plus 18%. Why 100%? Because she didn't make any payments in that first year. So you got to count the year with the 18%. Okay, and we did the same thing here and here. We just kept adding. 1 year, of course it got bigger because she's never paid any money off. So now what do you notice that's intriguing or interesting about all of this? Well, this seems to be consistent. This is how much it's growing every year. That hasn't changed. Okay, and what about if we look at this next problem? It says, well, wait a minute. To find at the end of 3 years, could she have taken year 2, the year 2 amount, which was right here, and taken the year 2 amount times 0.18? And wait a minute, but she ended up with 450 times 1.18 times 1.18 times 1.18. Well, weren't we just referencing that up here? 1.18, 1.18, 1.18. Here that is right here. And where does this 450 come in? Well, if you think back, this 450 is the initial amount that she started with. And how is it growing every year? By 1.18, 100% plus 18% more. So does her final expression correctly reflect? Yeah. Yes, it does. Because we see the original amount plus how much it's growing or how much she owes each year. Because she's not paying anything off. She keeps just rolling over the amount of money. So now it's asking us, can we write an expression for the amount of money she owes at the end of X years without making any payments in? Of course we can. So what is it going to be? An expression means we're going to take the original amount and we're going to multiply that by her rate of 1.18, and that's going to be raised to the X. What is the X reference? Here's our time. 450 is what she starts with. 100% always of the previous year plus 18% more give us and the time is our X. So that's how we would figure out how much money she owes. So moving on to the next page. Now we're going to be looking at comparing loans. So comparing loans is we've got 3 people. They're all are taking out $1,000 loans. And the thing that we're noting that they're all going to pay different annual interest rates. There's that word annual. Again, that means yearly. I'm going to abbreviate yearly. And we know that here are the 3 interest rates. So we have 12%, 24%, and 30.6%. And what we're supposed to do is for each loan, write an expression using only multiplication. So again, we're going back to what we were doing in that support lesson as well as lesson 14, where we're going to combine everything, make it simplified, make it efficient, make it more user-friendly. So that's what we're going to be doing. So again, if I take a look at 24% or 12%, let's start there. We know that that's a decimal of 12.112 or 0.12, sorry. 24% is 0.24 and loan C is 0.306. Okay, so now we know that after 1 year, and again, they're making no payments at all. So what I would do is I'm going to start with 1,000 times, remember, without making a payment, end of each year. So I've got to add 1 plus, 1 plus, and 1 plus. Okay, so if I add 1 to 0.12, I get 1.12. And I can go down for year 2. Remember, this is going to be to the power of 1 because that's 1 year. Then I've got 1,000 times 1.12 raised to the power of 2. So you can see what I'm doing here. What I'd like you to do is go ahead and fill out the rest of the table, pause the video, make sure, and then we'll talk about the graphs below. So you can see what I did was I went ahead and I filled in the whole table. You can see I used my exponent based on the year. Here's the 3, here's the 10, here's the x. And then notice what I did here just to kind of show you. I've got 1.24 and I multiplied it twice, which then I can simplify to be to the power of 2. I've got 1.24, so I've got all of these filled in, again, with each one. And then what I'd like you to do is, if you can, is you could use your calculator or you could use Desmos to graph, to do a quick sketch of these. But I really want to just talk about, if you think back to lesson 12 and 13 with regards to a graph and what it may look like, if we just look at loan A and we're looking at this amount right here, so we could see that we all started at 1,000. So if I go down to my graph, I'm going to put in 1,000 right here. So that's where everything starts, is at 1,000. Sorry about that. Let's do this. Starts at 1,000. Notice that the y-axis is the amount owed in dollars in the thousands, so I put 1,000 right here. Okay, so that's where everything starts. Okay, what else do I notice? I've got relatively close growth factors. I got 1.12, 1.24, and 1.306. Which one, let's just think about it. Which one is going to grow the fastest? Which is the bigger growth factor? Well, hopefully, you're going to see that it's this one. And what's the second one is B. And loan A is going to grow the slowest. It's going to be flatter. Okay? They're relatively close to 1. So there's going to be very little variation. In fact, they're fairly close. So I want you to think about the graphs. And if you were to do them without using Desmos, you know that they all started at 1,000 and they're going to have, one's going to be on top, in the middle, and on the bottom. So what's going to be your flattest graph? A. What's going to be the one in the middle? B. And what's going to be the one that's growing the fastest? C. So if you look at my graph right here, not the best, I mean, it's fairly accurate in that I did a quick sketch using my calculator. So here's C. Okay. Here's B. Again, they're all starting at 1,000. And the last one is, I'll use purple, is A. relatively flat. Okay, so we got A and we have B. Okay, so that is the bulk of what I wanted to make sure that you noticed, because I think that's the most important, is looking at the graph, relating the graph to our lesson up here with the growth rates, how we can determine which one is going to be the biggest or the fastest growing. So that means your interest rate is larger here, so you're going to owe more money. And again, noting that what did I do to get my factor? Remember, because this is at the end of the year, if no payments are made, again, we're always looking at it's 100% plus the interest rate more. So hopefully you were able to get everything down, and I will be creating a video, or Miss King is going to be making a video on your homework assignments.